You ever look at an old photo and just wish you could step inside? You know, not just look at it, but actually be there again, to just tilt your head a little and see what was hiding behind that corner? Well, that exact feeling is right at the heart of one of the coolest challenges in AI today: how to turn our flat, boring pictures into living, breathing, three-dimensional worlds. And the researchers behind this paper from Apple, they put it perfectly. The real dream here isn't just about looking at a memory, it's about reliving it. It's about taking that photo from your phone and turning it into a real spatial experience you can actually move around in. Right, so that's the big question, isn't it? It's a massive technical challenge. You've got to somehow teach a computer to understand depth and light and what's hidden behind other objects, all from just one single picture. And for a really long time, the answer always came with a huge catch. And that brings us to this fundamental dilemma, this conflict that's really defined this whole field for years. When you tried to generate these new 3D views, you were always forced to choose between two things: how fast you could do it and how good it looked. So on one side, you had these really powerful diffusion models. And yeah, they could create some pretty believable 3D scenes, but my gosh, were they slow. Then on the other side, you had older, faster methods, but the results, they were just kind of blurry, a little bit warped. They just didn't feel real. So you had a choice: quality or speed. You just couldn't have both. And to give you an idea of what slow actually means, look at this number: 830 seconds. That's almost 14 minutes. That's how long it took a top-of-the-line diffusion model, Gen 3C, to create one single new view from a photo. Can you imagine trying to explore a memory like that? It's not practical at all. So because of this trade-off, we were basically stuck. That whole dream of instantly turning any photo you have into a world you can walk through, it was just that, a dream. The tech was either way too slow to be useful, or the quality just wasn't good enough. It really felt like an impossible problem to solve. But then, a paper came out from those Apple researchers, and it introduced a brand new method that promised to completely shatter that deadlock, a method they called SHARP. And really, the name tells you everything you need to know. Single image, it only needs one picture. High accuracy, the results have to look fantastic. Real-time parallax, it has to be fast enough to give you that 3D feeling as you move your viewpoint around. Sharp was basically built from the ground up to solve that exact speed versus quality dilemma. And this, right here, is the absolute key. Sharp doesn't make you choose. It delivers on both. It's somehow unbelievably fast, and it produces results that are actually even better than the super slow methods. So, how on earth did they manage to do that? Well, the secret is in a totally different way of thinking about the image. Instead of seeing a photo as just a flat grid of pixels, Sharp sees it as a three-dimensional space that's just filled with points. Okay, so try to picture this. Your photo isn't a flat painting. Instead, it's like a sculpture made of more than 1 million tiny, colorful bits of dust, all just hanging there in space. That's the core idea. The AI's job is to look at your flat photo and, in an instant, figure out where every single one of those 1.2 million points should be in 3D. Now, the fancy technical name for this, point cloud, is a 3D Gaussian representation. It sounds super complicated, I know, but all it really means is that every single one of those million-plus points gets its own little list of instructions that defines everything about it. And here are those instructions. For every single point, the network decides. Number 1, where is it in 3D space? Its X, Y, and Z coordinates. 2, what's its size and shape? Is it a tiny speck or more of a splash? 3, what's its color? And 4, its opacity. Is it totally solid or is it kind of see-through, like glass? And by figuring all of that out for 1.2 million points, it builds the entire 3D scene in one go. So that's the theory. And it's a really clever way to rethink the problem, right? But the real question is, does it actually work? This is where we get to the data, and honestly, the results are pretty mind-blowing. Just look at this. On the left, we have the old state-of-the-art, Gen 3C, taking its sweet time at 830 seconds. And on the right, that's Sharp. It creates the entire 1.2 million point 3D model in less than a single second. That's not just a little better, that's a whole new category. We are talking over 800 times faster. It is literally the difference between waiting 14 minutes and boom, it's just there. Okay, but speed doesn't mean anything if the pictures look terrible. And this is where it gets really, really impressive. These are two common ways to measure how realistic an image looks, and for both of them, a lower score is better. And as you can see, Sharp doesn't just keep up with the slower model, it actually beats it. So this is the big takeaway. There's no trade-off anymore. Sharp is faster, and the result is measurably better. So what does all this mean? Well, when you get a piece of technology that is this fast and this good, it stops being just a cool research project. It starts to become a real tool that could fundamentally change how we interact with all of our digital stuff. I mean, the possibilities are just huge. Think about putting on a pair of AR glasses and seeing your family photos pop up as little 3D scenes in your living room, or just exploring your entire camera roll in 3D by tilting your phone. This could also give robots a way faster, better way to see the world around them. And for artists, it could open up entirely new ways to create. And that kind of leaves us with this really interesting final thought. For more than 100 years, a photograph has been a flat window, looking at one frozen moment. But now, we're right on the edge of that window becoming a doorway. If every single photo we've ever taken can be turned into a space we can go back into, well, that changes what a memory even is. And it really makes you wonder, how are we going to choose to see our past?